Curling by Max Slade and Tyler Hurt.
According to the World Curling Federation, the earliest evidence of curling dates back to the 16th century, somewhere between 1530 and 1569. The first recorded match took place in Paisley, Scotland, where John Slater and Gavin Hamilton threw rocks over ice in a little friendly competition. From that point until now, curling has evolved to sweeping ice, loud yelling, intricate biomechanics, and a worldwide phenomenon.
The first curling clubs were founded in Scotland in the 19th century, where curling was eventually spread to parts of the world where Scottish people had settled, such as Sweden, Switzerland, Norway, Canada, the United States, and New Zealand. The first official rules were established in Scotland in 1838 by the Grand Caledonian Curling Club, which was named the Royal Caledonian Curling Club in 1843 by Queen Victoria after she was captivated by a demonstration on how to play.
Curling received its first Olympic debut in 1924, where Great Britain defeated Sweden and France. Since that date, the World Curling Federation was formed, which re-established the rules of curling and is now the governing body of international curling competitions.
General rules and regulations. A regular sheet of ice is 150 feet long. The length from the hack to the center of the house is 126 feet long. No electronics are allowed on the ice except for a watch, which only can tell time. 2 teams of 4 play in one round. In playing in 10 ends, and each player throws 2 stones while their teammates sweep and direct the stones toward the house. 16 total stones are thrown in each end, and the team with the highest score after 10 ends wins.
The last stone in each end is called the hammer. Only one team can score in an end. The team with the closest stone to the center, that team scores 1 point for each stone closer than their opponent's best stone. There are 4 positions in curling. The lead goes first, followed by the second, the third or the vice skip, and then the skip. Skip is the leader of the team and yells out directions and the strategy to his teammates. Players stand in the hack, or the starting block, to push off with the curling stone. The stone must be released before crossing the hog line.
Impulse momentum theory. Movement is the quality of motion of a moving system. Linear momentum, or P, is equal to an object's mass times its velocity. P equals mv. And the momentum is a vector because velocity is a vector quantity. The SI units for momentum are kilogram meters per second. If either or both of the variables, mass or velocity, are changed, it will change the momentum of the object. Impulse is the amount of force applied over a duration of time and looks like F times delta t. Like with momentum, both of these variables can be manipulated to increase or decrease the total impulse of an object. Impulse and momentum are related by the impulse momentum theorem, which states that the change in momentum of an object equals the impulse applied to it. So, F delta t equals m delta v. When a curler starts to push off of the hack with a given force for a certain amount of time, they are creating an impulse. Then, when the curler lets go of the rock, the momentum is then transferred to it, which is what propels it down the ice to the house. Fine-tuning this impulse-momentum relationship is extremely important in curling because once the player leaves the hack, then they can't really generate any more momentum to the stone without compromising the line of the shot. With each shot, the player must carefully generate enough impulse to get the 44-pound stone to the house, but not too much to send it out the back.
Friction. There are 2 flavors of friction: static, the friction that resists the initiation of motion, and kinetic, the friction that resists the motion of a moving object. But we're going to focus on kinetic friction and how it plays a crucial role in curling. Friction is created by microscopic imperfections in surfaces, and when one object slides across another, the atoms from both surfaces interact with each other, creating an attraction that retards motion. Much like these cats, friction and curling have a finicky relationship. The overall role friction plays in curling takes place in the interaction between the ice and the stone. If the ice is too rough, then the stone can't glide smoothly across the ice to the house. And if the ice is too smooth, and yes, that's possible, then the bottom of the stone creates a suction cup effect with the ice and the stone doesn't travel to the house. So, the ice is actually sprayed with water between each end so that the suction cup phenomenon doesn't happen. Another way the ice is manipulated during a match is by sweeping. Originally, sweeping was done to get debris out of the way, but now it is used to reduce friction by getting rid of the bumps made by the water that was sprayed on.
Transfer and conservation of energy. The transfer of energy is directly correlated with the law of conservation of energy, which states that the total energy of an isolated system remains constant. For example, if a curling stone hits another with 30 joules, then the other stone will receive all 30 joules of energy if it is a perfectly elastic collision. This, however, isn't the case in real life because some energy is released as heat, some energy stays with the rock thrown, and the majority of the energy is transferred to the stone that was hit. This is actually how players use the laws of physics to their advantage. They use their stones to hit an opponent's out of the house while keeping theirs as close to the button as possible.
This year at the 2018 Pyeongchang Winter Olympics, Sweden won its third gold in the women's event. Canada won the first gold ever in the mixed doubles Olympic debut, and the United States won their first ever gold medal in the men's curling competition when Sweden missed a huge opportunity to take the lead in the middle of the seventh end, but missed just wide. This gave the U.S. opportunity to pull ahead, which they did, and scored a big 5 points at the end of the eighth end, later beating Sweden 10-7.